All right, hi everybody. So in this video, I just want to take a quick little tour of this GeoGebra applet that I linked in Canvas. That's going to be a good tool to work with these systems of linear differential equations and get a sense of what the solutions would look like in the phase plane. So I've opened this up and there's a default system in here that you would want to adjust. So we're working with the system x prime is 3x plus 10y. So I'm going to type that in there. And the y equation for y prime was minus 2y. I can type that in there. And now I can drag these points around in the phase plane and then see if I have an initial condition that starts at this point, what is the solution through that point going to look like? And the arrow also tells us the direction that we're moving along that curve. And so what we've seen is if we start off, say, at the point 3, 0, we observe that that's a pretty special solution in the sense that it's going to stay on that line y equals 0. And in the case of this system of differential equations, we actually head away from the origin as time goes on. And if we were to start at minus 3, 0, same thing, we're going to stay on that line, except now we move out to the left as time goes on. And another special solution was one that started at, say, 2 minus 1. And here we observe that any solution that starts on the line y is equal to minus 1/2 x is going to stay on that line. And these solutions headed in towards the equilibrium at the origin. And they kind of divide the plane up into these little regions. So if I want to know what does a solution look like at 3 minus 1 over here, we can see that it has to stay in between the line y equals minus 1/2 and the line y equals 0. And it's going to follow the arrows of those two special solutions. So once I have these special solutions here and here, for example, then I know if I were to start off at, say, at 0 minus 2 down here, this solution would have to kind of head this way and then head out over that way. So you can play around with these and probably get a nicer drawing than the one that we drew on the slide. But you should be able to get a good sense of what these solutions would look like if we can identify these key solutions. In this case, it was the solution that stayed on the line y equals 0 and the solution that stayed on the line y equals minus 1/2. So as we look at some other examples, we'll see how you could identify those solutions and then what they tell us about the entire phase plane.